Hello students, welcome to Aditya Academy. I am Dr. Ragini Arora and today we are going to start exercise 8.1 from Ncert. I hope you must have watched the introductory video of this chapter in which I had explained how to take 6 trigonometric ratios of acute angles of a right angle triangle. So starting from these questions, this is question 1 of exercise 8.1. In triangle ABC, right angled at B. So let us first make a right angled triangle. It is right angled at B. So I am keeping B as right angle and A and C as acute angles of this triangle. The sides of this triangle are given as AB is 24 centimeter, BC is 7 centimeter. So then we have to find the values of sine A cos A and sine C cos C. So in the introductory video, I had told you that when we have to take ratios, we always take trigonometric ratios regarding to some acute angle. We have two acute angles in this triangle, A and C. So we can take ratios according to either of these two angles. Now, if the only thing is when we consider one angle, according to that angle, we have to define what side is taken as perpendicular, what is taken as base. Because hypotenuse is fixed for this triangle. If angle B is 90 degree, the side opposite to right angle is called hypotenuse. And when we talk about base and perpendicular, we have to fix our angle first. Let's say I am fixing it as A. If A is the concerned angle, then this angle has to be between the base and hypotenuse. So I am fixing my base here. For A, base becomes AB and BC becomes perpendicular automatically, right? So this is the difference. If you take C, these sides get reversed. Hypotenuse is fixed because whenever 90-degree angle is fixed, the side opposite to right angle is hypotenuse. This is the longest side. You must remember this. Hypotenuse is the longest side of right triangle. So if I'm talking about the ratios, trigonometric ratios of A angle, what ratios are required here? Sine A and cos A. So for sine of A, sine ratio is sine of any angle is the ratio between the perpendicular and hypotenuse. So if we are taking for A, the perpendicular becomes BC here, BC, and hypotenuse is AC. Now also we have got those two values 24 and 7 in this triangle. So first of all we have to find the value of hypotenuse AC. In triangle ABC, AC square is AB square plus BC square. So by using Pythagoras theorem, we can find the third part which is not given in the question. AB square here is 24 square. BC square is 7 square. This is 576 added to 49. 9 and 6, 15. We have 625. AC square is 625, so AC becomes 25 centimeters, right? So AC is 25 now. Now we can put the values here. Sine of A is P upon H, which is BC by AC. BC is 7 and AC is 25. Then we have cos of A, which is base upon hypotenuse. Cos is the ratio of base and hypotenuse. What is base here? Base here is 24 upon hypotenuse is 25. So now we have found these two trigonometric ratios regarding angle A, right? The second part says we have to find sine C and cos C. That means now we have to take ratios for angle C, right? So here I am erasing these base and perpendicular. Why? Because when we change the angle, base and perpendicular gets reversed. Now see, if we are taking ratios about angle C, the concerned angle always falls between the base and hypotenuse. Hypotenuse is here, so now this side becomes the base and this becomes perpendicular. So if we have to find sine of C, it is the ratio of perpendicular and hypotenuse. Perpendicular here is AB upon AC, which is 24 by 25. Cos of C is base upon hypotenuse. Base here is BC upon hypotenuse is AC, which is 7 by 25. So I hope this is very basic concept which is clear. Now, if we change the acute angle, the ratios change according to the perpendicular and base. Next question is, in the given figure, you have to find tan P minus cot R. See, this is 90-degree angle. Side opposite to this is called hypotenuse. And since we have to find the ratio, one ratio is regarding angle P, the other ratio is regarding angle R. So we have to flip our perpendiculars and bases for both the things. Right now for angle P, if I am concerned with the ratio of angle P, this angle P has to be between base and hypotenuse. So this side becomes base and this becomes perpendicular. So this is the case for ratios of angle P. Right, now let me take those ratios first. First we have to check, like in triangle PQR, we are given these two values, PQ and PR. So by Pythagoras theorem, PR square is equal to PQ square plus QR square. PR square is known to us, which is 13 square. PQ square is 12 square and QR square we have to find. This is 169 minus 144 is QR square. QR square is 25. So QR becomes 5. Right? Now QR is 5 centimeters. Now what we have to find is tan P, tangent of P. Tan is the ratio between perpendicular and base of that angle. Now what is perpendicular regarding P? It is QR and base is PQ. So we have 5 upon 12. Right? Now let us come to, now I am erasing this. Perpendicular. What we have to do is we have to find cot of R. What is cotangent of R? Cotangent of R is the reciprocal of P by B. That means base upon perpendicular. Regarding angle R. So what we have to do first is, now we are taking the ratio about angle R. If R is a concerned angle, then R has to be between base and hypotenuse. So this side becomes base and this becomes perpendicular. Now this R is between base and hypotenuse. So base and hypotenuse is fixed. We have fixed our base. This becomes the perpendicular in this case. So now if we take the ratio of cot R, base is what? QR and perpendicular is PQ and that is 5 upon 12. So if we have to find the value of tan of P minus cot of R, that means it is 5 upon 12 minus 5 upon 12, which is 0. Right? Next question is, if sine A is 3 by 4, sine A is 3 by 4, nothing is given except this. So I can either take A here, B or C, you can take A here also. Let us keep B as the right angle. Now in triangle ABC, I have to take ratios about A. This is all about A and A and A. In triangle ABC, we are given that sine of A is 3 by 4. Now see, what you have to learn is sine A is the ratio between the perpendicular and the hypotenuse. We know that sine is a ratio between perpendicular and hypotenuse. So If let me mark these things in the figure. If angle A is a concerned angle, this is 90-degree, side opposite to this is called hypotenuse. Now for angle A, this side has to be the base. So this becomes the perpendicular. I hope this is clear now, right? So now the sine of A is a ratio between perpendicular and hypotenuse. Perpendicular is corresponding to 3. And if this 3 by 4 is a ratio, let us assume that the actual value of perpendicular is 3 times something. Let's say 3 times k. H is 4 times something, multiple of the same number 4k. Right? This 3 by 4 is basically the ratio. They are not the exact measurements of those sides. So we are assuming these sides to be exact measurement. And the perpendicular will be 3k and hypotenuse will be 4 times k. Because 3 by 4 is the reduced version of the actual lengths of those triangles, which is called ratio. So now P, perpendicular I am writing as 3k. Hypotenuse I am writing as 4k. Right? So in triangle ABC, AC square is AB square plus BC square. Right? So AC square here is 4k times whole square. AB square we have to find, and BC square is 3k times whole square. This is 16k square minus 9k square is AB square, which is 7k square. So now AB square comes out to be 7k square. So we find AB taking square root on both sides. This becomes root 7k. Square root of 7 is root 7. Square root of k square is k. So I can write AB as root 7k. Now we know all the three sides. 3k, 4k, root 7k. So what we have to find is calculate cos A and tan A. Cos of A is the ratio between base and hypotenuse. For A, base is AB, hypotenuse is AC. AB is root 7 times K. AC is 4K. So we have root 7 by 4. Then we have to find tan of A. This is the ratio of perpendicular and base. Perpendicular here is BC and base is AB. So it is 3k over root 7k. So we get 3 over root 7. Right? Next question is, given that 15 cot A is equal to 8. 15 cot of A is 8. So cot of A becomes 8 by 15. Right? Now what is the ratio of cot of any angle? Cot is the reciprocal of tan. Tan is perpendicular upon base. This is base upon perpendicular. So if we make a figure, let us assume that A is here, right? A is here and B is here and C is here, right? We have to keep A as acute angle, rest is adjustable. So if A is here and now I am taking ratio about angle A, what we can do, this is 90-degree angle, so the side opposite to 90-degree angle is hypotenuse. When we are concerned about angle A, this side becomes the base and this side becomes perpendicular. Right? Now cot of A is given as base upon perpendicular. That means AC upon BC, which is equal to 8 over 15. Now 8 over 15 is the ratio. So let us assume that let AC be equal to, AC represents 8 parts, BC represents 15th part. So this becomes 8 times H or K. And let's say BC represents 15 times K. Since they are not exact measurements, so I'm taking exact measurements to be the multiples of these ratios. AC becomes 8K, BC becomes 15K. Now placing them here, BC is 15K, AC is 8K. So what we can do is, in triangle ABC, AB square is AC square plus BC square. So AC here is 8K. 8K whole square, BC is 15K whole square. This is 64K square plus 225K square, which is 2, 5 and 4, 9, 289K square. So what is AB now? This becomes 17K. AB is 17K, right? So now we have to find sine A and secant A. Sine A is the ratio of perpendicular and hypotenuse. So now according to this, perpendicular is this side. For A, perpendicular is BC upon hypotenuse, which is AB. So we have perpendicular is 15K over 17K, which is 15 by 17. Cos of A. What is cos? Sorry, we have to find secant of A. This is secant of A. Secant of A is the reciprocal of cos. Cos is base by hypotenuse. This is hypotenuse by base. Hypotenuse here is AB and base is AC, which is 17K over 8K. So we have 17 by 8. Right. So the next question is, when we have given that sec theta is 13 by 12, sec of theta. So here they haven't given us ABC, so we can name our triangle anyhow, like PQR. And we can fix out of P or R, we can fix any of these two angles as theta. I'm marking this as theta. Now this says, given that secant of theta is 13 by 12, right? Secant of theta is 13 over 12. Now again, this is the ratio. Secant is hypotenuse upon base. Hypotenuse upon base. Now I have fixed this as theta, right? And this is right angle. So this side has to be hypotenuse. Angle theta is fixed here. So this becomes base and this becomes perpendicular, right? Now this represents that hypotenuse is which side? This is PR. And base is which side, which is QR. Now this is equal to 13 by 12. If these are the ratios, let PR is equal to 13K. Let QR is equal to 12K. Let these be the exact measurements of these two sides. So now what happens? PR is 13. PR is 13K. QR is 12K. Now in triangle PQR, PR square is PQ square plus QR square by Pythagoras theorem. PR is given to us as 13K whole square. PQ square is this we have to find. QR square is 12K times whole square. This is 169K square. PQ square plus 144K square. So PQ square becomes 169K square minus 144K square, which is 25K square. So PQ becomes 5K. Take the square root from both the sides. This becomes PQ is 5K. Now we have got all the three sides. Then we have to find all trigonometric ratios. Now we go for sine of A, which is P by H. Perpendicular is PQ upon hypotenuse PR. PQ is 5K and PR is 13K. So we have 5 by 13. Next is cos of A, which is the ratio of base and hypotenuse. Base here is QR, and this is PR. So we have 12K over 13K, which is 12 by 13. Okay, then we have tan of A, which is perpendicular and base, ratio of perpendicular and base. Perpendicular here is PQ, base is QR. So this is 5K over 12K, which is 5 by 12. Then we have cosec. Cosec of A is basically the ratio of hypotenuse and perpendicular, reciprocal of sine, which is 13K over 5K. So we have 13 by 5. Reciprocal of cos is secant, which is given to us. So we have to find only cot of A. Cot A is base upon perpendicular. Base is QR upon perpendicular is PQ, which is 12K by 5K. So we have 12 by 5. Right? This way we have found all the trigonometric ratios. Next question is angle A and angle B are acute angles such that cos A is cos B. Then show that angle A is equal to angle B. So here what we can do is, we are not given that they are in the same triangle or in different triangles. So let me solve this by using, let C be the right angle in this case. Let us put this, as we always mark figures in anti-clockwise direction. So if I am keeping this as A, let this be B. Now, angle A and angle B are acute angles such that cos of A is equal to cos of B. So in this case, we have to consider the ratios of both the angles B as well as A. So, if I am taking the ratios according to angle B, now, first of all, I am taking ratios according to angle B. Now, if I keep angle B as a concerned angle, that means I have to keep this side as base, and this is obviously hypotenuse. This becomes perpendicular for angle B. So if I take ratio as cos A is equal to cos B, the value of cos B is base upon hypotenuse. What is base here? Base is BC, hypotenuse is AB. So the value of cos B is BC over AB. Now if I take cos of angle A, now I am erasing this thing. Hypotenuse is fixed. Hypotenuse is fixed. Now I am taking ratios about angle A. So this has to be based between base and hypotenuse. For angle A, AC becomes base, BC becomes perpendicular. So now what we have to do is cos of A is base upon hypotenuse. Base upon hypotenuse means AC upon AB. So now we are given that cos of A is equal to cos of B. That means BC upon AB is equal to AC upon AB. So since both the denominators are equal, we can say that only numerators are equal. AC is equal, BC is equal to AC. BC is equal to AC. Right now in a triangle, if two sides are equal, then their base angles are also equal, which is also in layman language we call it isosceles triangle property. So side opposite to BC, angle opposite to BC is angle A, and angle opposite to AC is angle B. So when the two sides are equal, their opposite angles are also equal. The reason being angles opposite to equal sides are equal. Hence we have proved that angle A is equal to angle B. Next, given that cot theta is 7 by 8. So first of all we have to make this triangle. Fix theta here. Let this be triangle ABC, right angled at B. Let angle C be represented by theta. So it is given that cot theta is 7 by 8. Now cot is the ratio of base and perpendicular. So if we are taking this as our theta, this side has to be base. This will be perpendicular and this is the hypotenuse. Now let actual sides be, these are the ratios. Cot theta is the ratio between 7 and 8, means actual sides are, base is BC and perpendicular is AB. So let us assume that BC is 7K. BC is 7K and AB represents 8K. Right? So I'm taking these ratios, BC as 7K, AB as 8K. BC as 7K, AB as 8K. So in triangle ABC, AC square is equal to AB square plus BC square. This we have to find. AC square we have to find. This is 8K square plus 7K square, which is 64K square plus 49K square, which is 113K square. So AC becomes square root of 113K. Right, now we have to find, in the first case, we need the values of sine theta is P upon H. P upon H. What is P here? 8K. So 8K upon H is root 113 over K. So sine theta becomes 8 over square root of 113. What is cos theta? Cos theta is base upon hypotenuse. Base is 7 upon root 113. Right? Now we have found these two values. We require only these two here in the first part. So in the first part, I am putting the values directly here in this expression. 1 plus sine theta. Sine theta is 8 over root 113. 1 minus sine theta, which is 8 over root 113. In the denominator, we have 1 plus cos theta. 1 plus 7 over square root of 113. 1 minus 7 divided by root 113. Right? I haven't copied this expression because I have less space here. I've directly put these values of sine theta and cos theta into this expression. Now I'm solving this. In the numerator, you can see that this is a plus b, a minus b, which is a square minus b square. 1 square is 1. This becomes 64 over 113. 1 denominator also a plus b, a minus b. So a square is 1 square minus b square is 7 square, which is 49 over 113. Now if you solve this, you take the LCM. This is 113 minus 64 over 113. And here you take LCM. This is 113 minus 49, and this 113 goes into the numerator. This is 13 minus 4 is 13 minus 4 is 9, 10 minus 6 is 49, divided by, this is 113 minus 49, which is 64. So we have 49 by 64. This is the value of first expression. This is 49 by 64. Right? Next we have to find, second part is cot square theta. Now what is cot theta? Cot theta is given to us as 7 by 8. So this is simply the square of this. Cot theta is 7 by 8. So cot square theta becomes 7 by 8 whole square. That is 49 by 64, which is again the same value. Right? Next question is, it is given that if 3 cot A is equal to 4. That means the value of cot A is 4 by 3. Cot of any angle is the ratio of base and perpendicular. So now I am making this triangle. Here you can label this as ABC. So A we have to keep as acute angle. So taking anti-clockwise, this is the relationship, right? Now we have to find the ratio regarding angle A. This becomes base, this is hypotenuse, this becomes perpendicular, right? So what we have to find is tan, cos, sine. Okay. First of all, find the values. If cot A is B by P, what is the ratio? Base here is AC. Perpendicular is BC. So let AC is equal to 4K and BC becomes 3K. So in triangle ABC, here our AB square is equal to BC square plus AC square. What we are given is AC is 4K. Let AC be 4K, BC be 3K. This is 4K whole square plus 3K whole square. So we have 16K square, 9K square, which is 25K square. So AB becomes 5K. Take square root on both sides. AB is 5K. Right? Now let us find the trigonometric ratios. Sin A is the ratio between perpendicular and hypotenuse. Perpendicular here is 3K. Hypotenuse is 5K, which is 3 by 5. Then we have to find cos of A, which is the ratio of base and hypotenuse, which is 4K upon 5K. It is 4 by 5. Next we have to find tan A. Tan A is B upon B. Perpendicular here is 3K and base is 4K, so it is 3 by 4. Now we have to take the LHS first. LHS here is 1 minus tan square A upon 1 plus tan square A. Now let us put the value of tan A here. Tan A is 3 by 4. 3 by 4 whole square. 1 plus 3 by 4 whole square. So this is equal to 1 plus 9 by 16. Sorry, 1 minus, here it is, minus 1 minus 9 by 16, 1 plus 9 by 16. Take LCM. 16 minus 9 is 7 by 16. 16 plus 9 is 25 by 16. So we get 7 by 25. 7 by 25 in the value of LHS. Now if we solve RHS, it is cos square A minus sin square A. So this becomes cos A is what? Cos A is 4 by 5. 4 by 5 whole square. Sin A is 3 by 5 whole square. This is 16 by 25 minus 9 by 25. So we have 16 minus 9 is 7 by 25. So we can say that LHS is equal to RHS. We had to check. Yes, they are equal. Now the next question is, in an angle, in triangle ABC, right angled at B. Okay, now we have to keep right angled at B. ABC right angled at B. So now I am writing C here and A here. Right angled at B, this side becomes hypotenuse. Now in this question, we have to find ratios of both the angles A and C. So firstly, I am finding the ratios about angle A. If I fixed angle A, this side becomes base, this becomes perpendicular, and this is hypotenuse. Now it is given that tan A is 1 by root 3. So what I can do about this? Tan A is P upon B. P upon B. So if I fix the ratios, Let this be K. Let this perpendicular becomes K and this root 3 becomes root 3K. Base is root 3K. Base is root 3K and perpendicular represents 1K. Base represents root 3K. Perpendicular is 1K. Now in triangle ABC, AC square is AB square plus BC square. So we have root 3K whole square plus 1K square. This is 3K square plus K square, which is 4K square. So AC becomes 2K. This is 2K. Now I am writing ratios about angle A first. What are the values that we require? Sin A, cos A, sin A. And similarly, we require cos C, sin C. For A, cos A is base upon hypotenuse. Base is for A, base is this. Root 3K upon hypotenuse, which is 2K. So we have root 3 by 2. And for sine of A is perpendicular upon hypotenuse. Perpendicular is 1K upon hypotenuse is 2K. So this becomes 1 by 2. Right? Now I am taking ratios about, this is cos C. Cos C is base upon hypotenuse. But for C, we have to reverse these sides. Eraser. Okay. Now this becomes, the values of sides do not change. They are fixed. We have only to flip the sides between base and perpendicular. Now for angle C, this becomes perpendicular, this becomes base. The values of sides are same, right? For cos C, base is what? Cos C base is 1K and hypotenuse is 2K, which is 1 by 2. For sine of C, it is perpendicular upon hypotenuse. Perpendicular is root 3K upon hypotenuse is 2K. So we have root 3 over 2. Now since we have found these values by the given thing, like tan A was given to us, now we are doing the first part, which is sin A cos C plus cos A sin C. What is sin A? Sin A is 1 by 2 multiplied by cos of C, which is 1 by 2 plus cos of A sin of C. Cos of A is root 3 by 2. Sin of C is multiplied by root 3 by 2. So here we have 1 by 4 plus root 3 into root 3 is 3 by 4, which is 4 by 4, that is 1. And the second part is cos of A. Cos A cos C minus sin A sin C. What is the value of cos A? Cos A is root 3 by 2. Cos C is 1 by 2. They are in multiplication. Sin A. Sin A is 1 by 2. Sin C is root 3 by 2. So we have root 3 by 4 minus root 3 by 4. That is 0. Right? So now we are done with question 9, and the final question is PQR right angled at Q. So first we have to make the right angled at Q, right? PQR. This is 90-degree angle. This becomes hypotenuse. What we have to do is, we are given that PR plus QR is 25. PR plus QR is 25 centimeter and PQ is 5. PQ is 5 centimeters. Determine the values of sin P, cos P, tan P. So we have to take the ratios about angle P only. But before that, we have to find the values of these two sides. We are only given the exact value in terms of PQ. We have to find QR and PR. Now in triangle PQR, by using Pythagoras theorem, we can say that PR square is PQ square plus QR square. Now we are not given any value here, only PQ square is given. So we can write like PR square minus QR square is equal to PQ square. Now why I have written this? Because we have got this in the terms of identity A square minus B square, which is PR plus QR into PR minus QR. This becomes PQ square, which is 5 square. Now we are given the values of PR plus QR as 25. So we get here as PR minus QR is 25. So PR minus QR becomes 1. This 25 divided by 25. So we have PR minus QR is equal to 1 and PR plus QR is 25. If we add these two equations, we get 2PR is equal to 26. So PR is 13. PR is 13 from here. This is 13 minus QR is equal to 1. So 13 minus 1 is QR. QR is 12. Right? Now we have got exact values of these sides. This is 12 centimeter and PR is 13 centimeter. Now this becomes very easy. We have to find sine P. Regarding P, this has to be base. This has to be perpendicular. So if we have to find sine of P is the ratio of perpendicular and hypotenuse. Perpendicular is 12. Hypotenuse is 13. Then we have cos of P. Cos P is base upon hypotenuse. Base is this PQ, which is 5. Hypotenuse is 13. Then we have to find tan P, which is P upon B. P is this QR, which is 12. And P in this case is, P is QR and which is 12 and base is PQ, which is 5. So this is sin P, cos P and tan P. Now this is the last question of this exercise. This true-false question we have to answer. The first thing is we have to justify also. State whether the following are true or false and justify your answer. The value of tan A is always less than 1, which is false. Because here if see, these true false questions are now, since we have done only exercise 8.1, we are supposed to answer these true false according to the concepts which I have used in this exercise. But when you will be getting this question in examination, you are not supposed to do that by only this method. If it is false, you can say that we know that the values of angles, acute angles, like tan 45 is 1 and tan 60 is root 3, which is 1.732, and this value is greater than 1. So this is false. Right? Next is secant of A is 12 by 5 for some value of angle A. If in a right angled triangle, we keep this angle as A, B and C. If we are finding the values of trigonometric ratios of angle A, this becomes hypotenuse, this becomes base, and this is perpendicular. Now what is secant of A? Secant of A is hypotenuse upon base, and we know that hypotenuse is the longest side. So if we are taking this is given to be 12 by 5. If hypotenuse is greater than 5, greater than the denominator, that means hypotenuse is the longer side as compared to base. As long as this is true, it is true. Because, or in rough manner, we can say that secant of A is always greater than 1. Because in that case, hypotenuse, secant, we get hypotenuse in the numerator. And hypotenuse is the longest side. So this ratio has always to be greater than 1. So this is true. Next is cos A is the abbreviation used for cosecant of angle of A. This is false. This is true. This is false. Why? Because cosecant is cosec A. Cosec A. Cosecant is the reciprocal of sine of A. So cosecant is not abbreviation of cos. For cos, the proper name is cosine. Cos is the abbreviation of cosine. So you can replace this word by cosine. Cos is the abbreviation used for cosine of angle A. Cot A is the product of cot and A, which is false. Now why it is false? Because this cot and A are not two different terms which are getting multiplied. These are not the product of cot and A. Basically, we are finding the trigonometric ratio of cot A. So this is false. This is not the product. Basically, this term represents trigonometric ratio of angle A. Right? Then we have sine theta is 4 by 3. This is also false. Why? See, this is the same reason. If we keep this angle as theta, right? This becomes perpendicular because the concerned angle lies between base and hypotenuse. So now, what is sine theta? Sine theta is perpendicular upon hypotenuse. So this I have told you, hypotenuse is the longest side. So if we compare perpendicular and hypotenuse, your denominator should be larger. This hypotenuse should be larger. So, and in this case, instead we have longer side in the numerator. So this cannot be the value of sine of any angle, because sine of any angle is always less than 1 in terms of positive values. Otherwise, later on you will be learning that sine theta lies between -1 and 1. Its value never becomes more than 1. So this 1 by 3 is greater than 1, so which is false. Sine of any angle theta lies between -1 and 1. It cannot exceed 1. Right? So now we have finished exercise 8.1 from NCERT. I hope these concepts are clear and you liked watching this video. So please like, subscribe and share it with your friends. Thank you.